Okay, now I'm start recording already. Recording. Alright. So okay. So this part actually Hagen principle. Okay. I already taught. Okay. For some class I already taught. So I will go through quickly this part. Yeah. So Hagen principle is about how the wave propagate, yeah, how the wave travel from one point to another point. Okay, so as you can see, Hagen principle is like it generate, each point of the wave generate a new wavelet, and then that's why it form a new wave front, like that lah. Okay, so this one I will talk more about. I will teach more about this later. Yeah, Hagen principle. Yeah, constructive and destructive interference. So I believe you also learned this before in your SPM. Okay, constructive interference, interference membina, destructive interference, interference membinasa. Okay, memusnah. So it produce bright or dark region. Yeah, bright or dark fringe. Yeah, like you see, these two wave combine become a bigger wave. That is called constructive interference. And then destructive interference is the direction is, you see, opposite. Yeah, the first wave and the second wave direction. The wave direction is, one going down, one going up. So they are opposite. So when they combine, they get destructive interference. So constructive interference, you get bright fringe. Destructive interference, you get dark fringe. Okay. So you learned this before, yeah. I will talk about this more later in the tutorial. Okay. So today I want to pay attention more on double slit, yeah, double slit and interference, yeah, and also path difference. Some several concepts lah, yeah. So what is meant by coherence? This is also a very good important concept. You must know coherent. Coherence means the source must have same wavelength or frequency, and the source must have constant phase difference between them. So like let's see these two wave. This is incoherent. Yeah, incoherent. Like this one is coherent. Same wavelength, same frequency. Constant phase difference. You see the first wave and second wave have constant phase difference of 1 lambda. Yeah, the second wave and third wave also have constant phase difference of 1 lambda. Uh, the first wave and second wave have phase difference of 2 lambda. Okay, anyway, what is meant by coherent? Maybe I can show it a bit clearer over here. So hold on a second. I hold on a second. So I need to take up my Kaiser. Okay. Okay, good. So coherent, coherent wave. What is mean by coherent wave? Okay, coherent wave. Coherent wave means they have what? Remember, they have same wavelength or frequency. Secondly, there must be a constant phase difference. Oops. Okay, what does it mean by these two? Coherent. So same wavelength or frequency. That means I can say is for example, I give you two wave. This is the first wave. Oops. The first wave. Okay. First wave, and then I have the second wave. Okay. And then another example. Second wave is like this. Oops. Not really nice, not really beautiful. Okay. So, so I want to ask you, which of this pair of wave have same wavelength? Which one? The set A or set B? Which set of wave has same wavelength? Class, tell me. Class, which set has same wavelength?
A, sir.
Louder, please.
A.
What about the others? Are you listening, class? Are you listening to the class? I need response. Don't just write in the message. Yeah, you just open your mic and speak it. Yeah, talk to me. Yeah, class. Can you speak it? Speak it.
Okay, sir.
Yeah. So which set, class? Which one has same wavelength? Don't waste the time here. Set A. Yeah. Okay, good. So it's set A. Because they have the same wavelength, right? Same wavelength. Also same frequency. This one has same wavelength or same frequency. Or same frequency. Yeah. Same wavelength and same frequency. But for B, this one has the wavelength. This one is you see, this is the wavelength, but this one, the wavelength is so short, isn't it? Yeah, 0. So this one has a long wavelength, small wavelength, yeah, short wavelength. But this one has low frequency, and this one has high frequency. Correct or not, class? So which one are coherent? Which set are coherent? Coherent wave? Class, come on. Which set are coherent? Yeah. A, good. Yeah. So these are coherent wave. Yeah. These are coherent wave. So these are coherent wave. Coherent wave. Yeah. This one is incoherent. Incoherent wave. Class? And one more thing, class. If you have same wavelength, means they are same type of wave. Same type of wave. And incoherent wave, actually there are different type of wave. Different types of wave. Okay. Same wavelength, that means they have a single wavelength lah. Single wavelength. This one has two different wavelength. Yeah, they have different wavelength. Yeah. So okay, so this one has different wavelength or frequency. Yeah, so they are incoherent wave. They are different type of wave. We have a special word for same type of wave. We call it monochromatic. Monochromatic wave. Monochromatic wave. Monochromatic wave. So I can say if you have a single wavelength, same wavelength, means these two waves are same color also. Same color. For example, let's say I can say the first wave is red light, then the second wave also red light, because they have the same wavelength. They have the same wavelength, so they have the same color also. Monochromatic means one color. Mono. Chrome is about color. Right or not, class? When talking about chrome is about color. So monochromatic means single color. So if the first ray is a red light, the second ray must be a red light because they have the same wavelength. But for this one has a longer wavelength. It's maybe, let's say it's a red light. The second one has a shorter wavelength. This one should be maybe violet. So this one is violet light. Different type of wave. Different type. Okay? This is not monochromatic. This is not monochromatic. So the first one is red color, red light. The second one is violet light. So these red light and violet light, they are incoherent. They are incoherent. But red light with red light, they are coherent wave. So if you want to have, let's say, like, you know, just now you learned about constructive interference and destructive interference. The condition to have constructive or destructive interference is both waves must be coherent. Like you see this one, the first wave and second wave, they have the same wavelength. They have same wavelength. Only then you can have constructive interference. Like these two one also, they are coherent because they have same wavelength. Just like they are opposite direction. So but they still have the same wavelength. Same wavelength. So that means the first one is red light, the second one also red light, not red light with violet light. It's red light with red light. So when they have coherent wave, when they are coherent, only then they can have destructive interference. So constructive and destructive interference must have two waves with same wavelength. Understand? Must be coherent. Okay, what is constant phase difference? Constant phase difference is like this lah, like this destructive interference. This one, the first wave and second wave, they have phase difference of half wavelength. That's why the direction is opposite. You see that? They have phase difference of half wavelength, but they are still coherent. What I can say is like this. Maybe I should put it this way. Yeah. So you can see the okay, I give you example. So this is the first wave. Okay, and the second wave is starting maybe over here. Yeah, this one is start from here. But the second wave is start from here. Oops. Sorry. Not a beautiful drawing, Okay, you know what? Genius, isn't it, class? Okay, so you see, so you can see these two. Okay, you see these two waves. They have a phase difference of half wavelength. Or I can say they have a constant phase difference. We put it as you know, what is a symbol again? Let me check again. You know, sometimes I will forget things. Yeah. This one. Yeah, delta phi. So delta phi equal to delta phi put in radian. Yeah, delta L, delta phi. This is phase difference and path difference lah. Yeah. Later you will learn about this phase difference. Yeah, don't worry. So right now, phase difference. You see, you will learn about this later on. Just after this. This one. So this one is a phase difference of pi radian. Yeah, or path difference of half wavelength. Okay. This one in meter lah. Yeah. This one in length. This one in phase. So this one is called phase difference. This one is called what? This one is called path difference. Path difference. Do you see class? That means this the first wave is start earlier compared to the second wave is start later. They have a phase difference of pi radian. Phase difference of pi radian and also path difference of half wavelength. Yeah, the first one is in radian. That means it is in terms of angle. You know, angle. Sudut. Talking about phase, isn't it? Phase is about angle. Path is about length. It's about length. So that's why it's in meter. The unit is in meter. Okay, class? So the difference is half wavelength. So you see this is half wavelength. So the difference is half wavelength. Or half wavelength is exactly pi radian lah. Because we know that one wavelength constitute for 2 pi radian. Correct or not, class? So if half wavelength, half of it is pi lah, pi radian. Okay, class? So this is phase difference, but they are still coherent. Understand? They are still considered coherent wave. Do you understand why they are coherent? Just simply because they have the same wavelength. See that? They have the same. Oops. They still have the same wavelength. They still have the same wavelength. Yeah, you compare their wavelength, it's the same. From here to here, here to here, they have the same wavelength. So they are still coherent. They have a constant phase difference. Yeah, they have a constant phase difference of pi radian. Yeah, this is this part lah. This part is the phase difference. Understand? This part is the phase difference. They have a constant phase difference of pi radian or constant path difference of half wavelength. Okay, class, understand? Understand? They are still same wavelength. Yeah, coherent. They are coherent. Okay, that is what it means lah. Okay, coherent wave must have same wavelength and constant phase difference. The phase difference can be 0, can be pi radian, can be 2 pi radian. So constant phase difference. Yeah. Okay. You know why, class? Why we say same wavelength is considered same type of wave? Do you understand why same wavelength considered same type of wave? Why is it called single wavelength is considered only one color, monochromatic? Why is it same wavelength is referred to same type of wave? Yeah, just because that if you still remember what you learned in your SPM, you see before this diagram, electromagnetic wave range. Let me find something. Okay, let me show you. Yeah, so electromagnetic wave. Yeah, let me show you electromagnetic wave range. Let me this one. Yes, this electromagnetic spectrum. That's right. Let me copy this and put it here. Yeah, if you still remember, oops, so small. Yeah, I got it. Yeah, class, this one. Remember this electromagnetic spectrum? See that this one, class? Why is it cannot be moved? Okay, set it, set the picture. Okay, class. Remember this electromagnetic spectrum? So you see different wavelength different wavelength is considered different type of wave. Like example, like you see, I say red light. Red light has a longer wavelength compared to violet light. Violet light is shorter wavelength. If red light, yeah, the red light I considered like this one. Red light, they have longer wavelength. Yeah, red light is longer wavelength. Violet is considered shorter wavelength. Yeah, in fact, you see the red light, visible spectrum. Yeah, see the here visible spectrum, the red light, then to violet light. Yeah, actually, I have acronyms lah. Yeah, Michael Jackson Kiss is boss, boss biru in USA. Michael Jackson kissed his boss in USA. Yeah, merah, jingga, kuning, hijau, biru, indigo, ungu. Okay, okay. Never mind. That's just some jokes lah. Okay. Anyway, you can see in red light is considered like near to the range of infrared, violet near to the range of ultraviolet light. So I can say that red light has a longer wavelength. Violet light has a shorter wavelength. Okay. Ultraviolet light, shorter wavelength. Red light, longer wavelength. So if you want the value, the wavelength value for red light is 700 nanometer. For red light lah, red light. For violet light is actually 400 nanometer. So visible spectrum, for visible spectrum, yeah, the visible spectrum, that means the light you can see, the human eye can see. Yeah, actually the wave that the light has many kind of wave our eye cannot see. Understand? Our eye is not. I can say that the visible range is only this part, this small part. This very small part from, you see, this line to this line. Only this part of wave we can see with our human eye. The other part all we cannot see. They are invisible. Our eyes are not sensitive enough to detect all the radio wave, microwave, infrared, ultraviolet, X-ray, gamma ray. Our human eyes not sensitive enough. But if some animals can, like birds or dolphin, they can detect this kind of wave lah. They can see it. Yeah. But our human eye cannot detect it. Yeah, our human eye can only see this range only. But even though our eye cannot see this wave, but this wave still exists. Some wave they exist, but it's just that our eye cannot see it. We can only see a very small part only. Okay, so the human eye, our human eye can only see the range of 400 to 700 nanometer light range. Yeah, visible, our human eye can see. Yeah, our human eye can only see this range of light only. If you want to see wavelength 300 nanometer, cannot. Our human eye cannot see wavelength 300. Our human eye also cannot see wavelength 800. Cannot see. Our eye can only see 400 to 700 nanometer only. Nanometer, yeah. But do you see that actually the wave exists from 0.0005 nanometer gamma ray. It exists, but of course we cannot see it. We can only see this range only. Yeah. Radio wave is 5 trillion nanometer. We cannot see it. That's why a radio wave, because it has a very long wavelength, so that's why it can diffract a lot. It can, we can listen to radio, because because it has very long wavelength. That's why, actually before this is about the Huygens principle. You see that diffraction is most obvious when the gap is approximately the size of the wavelength. For example, like radio wave. Understand? Radio wave has a very long wavelength. Very long wavelength. So that's why it has a lot of diffraction. There's a lot of diffraction. That's why the radio wave can go over the mountain, go over from one door to the next door. Yeah, transmit to all. Everybody can hear the radio, right? Can listen to the radio. Because why? Because very simple. Radio wave has a very long wavelength, so has a lot of diffraction. Yeah. So this you can just remember. Yeah, because radio wave is so big. Yeah, it's so big. So radio wave is considered, or you can say the size of gap. The size of gap, the gap size, or the obstacle size is so much, so much smaller. Yeah, you can say so much smaller compared to the wavelength. Yeah, if so much smaller than wavelength, so it's like, I give one example, like when the gap is the gap size. Gap size means the size of A. Size of A. When the wavelength is so big, when the wavelength is so big, so it has a lot of diffraction. It can go to more direction. Yeah, diffraction a lot. Yeah. So say diffraction also high. So that means can travel a lot places. Because a lot of diffraction. Understand? So that's radio wave. Because it has very long wavelength. Okay, then this one I will talk about it later when I talk about when I teach about Huygens principle. Okay, I just want to show you that different wavelength, different type of different wavelength. Yeah. One simple thing to say over here is it's too small. The word bit bigger. Okay, let me make it bigger. Okay, so I can say different wavelength means different type of wave. Same wavelength means monochromatic wave or coherent wave lah. Understand, class? Different type of wave lah. Like gamma ray has a very short wavelength. Radio wave has a very long wavelength. So they are radio wave and gamma ray. They are different type of wave. Even the red light and violet light, they are different type of wave. This is red light. This is violet light. When you have different wavelength, 700 or 400, yeah, so they become different type of wave already. Red light and red light and violet light. Yeah. So different wavelength means different type of light, different type of wave, or we can say different color also. Different. Yeah. So different type or different color. Okay, understood class? Okay, I think enough lah. All right. So coherent waves means they must have same wavelength lah. Yeah, single wavelength means single color, single type of wave, same type of wave. Okay, because different wavelength means different type of wave already. You have radio wave, microwave, infrared. These are long wavelength, and ultraviolet, X-ray, gamma ray. These are short wavelength, very short wavelength. So different wavelength means different type of wave. You have a spectrum of it, and our human eye can only see this short range only. This the other type of wave we cannot see. Okay, and later on we will learn about energy also, but this one in next time lah. Okay, so carry on class. Coherent, yeah, coherent. So coherent can have in phase and anti phase lah. In phase means they start with let's say crest with crest in phase. Anti phase means one with crest, one with trough. Like this one, anti phase, they have destructive interference lah. Like in phase means become constructive interference. Okay. See, condition for interference of light. This is important, class. So interference between the two light can only take place if the source must be coherent. They must have same frequency. Must be monochromatic, single wavelength. That means understand? Like what I say just now. Like you see this one. These two waves can have interference, can constructive or destructive interference. Yeah, red light with red light can interference. Yeah, but red light with violet light, how do you interference? How can you have constructive or destructive interference? They are not even at the same frequency, not even the same wavelength, so they cannot have constructive or destructive interference. But red light and red light, yes. Yeah. So remember the condition. Just type it out here. Condition. Okay. So conditions for constructive or destructive interference. Okay. So what are the condition, class? What are the conditions? They must have the same. They must be coherent. Yeah, must be coherent. Coherent wave. Must have coherent wave means they have the same wavelength. Same wavelength or same frequency. Must be monochromatic. Or we can say same type of wave. And thirdly is almost same amplitude also lah. Almost same amplitude. Almost same amplitude. Because why we say like that? Because if not the same amplitude, how can have constructive interference? Let's say I have the first wave is such a high one. Such a big amplitude. The first one. The second wave is also green light. Let's say green light. Same type of wave. Very small wave, small amplitude. Very small amplitude. Small amplitude. A2. Can they have destructive interference? Bolehkah dia destructive interference? Destructive interference means the other way lah. Destructive interference. Bolehkah dia destructive interference? Ya, tengok dia punya puncak Boleh tak dia cancel totally? Can they cancel totally? Cannot. Cannot. They cannot cancel totally. They must have same amplitude. They must have same amplitude. Baru boleh cancel totally. See? They must same or approximately same amplitude to have total cancellation at minimum or obtain a good contrast of maximum. Okay? And then distance between two coherent sources should be small as possible of the light wavelength. That means the two source of light, if you want to have a constructive or destructive interference, like this one, you want to have constructive or destructive interference. Constructive or destructive interference, these two waves must be near to each other. Yeah, very near to each other. If very far from each other, you cannot have constructive interference. Okay, that's it lah. Yeah, they must have a. So important thing is the distance is small lah. Yeah, small distance between the two source. To have constructive or destructive interference must have small distance. Okay. All right. So that's condition for this interference. Now, important lah. Yeah, remember this. Okay, path difference. Let me talk a bit about path difference. So, what is path difference? Path difference is actually difference in distances traveled by two light waves meeting at one point. So path difference is actually just now I explained already. Path difference of one wavelength correspond to phase difference delta phi of 2 pi. This path difference decide whether constructive or destructive interference occur when they arrive at one point. See that, class? Let me explain. Let me explain, class. Yeah. Wow. Just I thought about this. Okay, so let's talk about path difference, class. What is path difference? Path difference. Such a small word. Who see it? Path difference. Yeah. And the one we have to call phase difference. Phase difference. Path difference. In the unit is in meter lah. Phase difference means in radian lah. Yeah. This path difference is delta L. Phase difference is delta phi. Okay. And these two, if you have path difference of 1 lambda, that means you also have phase difference of 2 pi radian. 1 lambda meter, 2 pi radian. Understand? If you have a path difference of 1 lambda, means you have a phase difference of 2 pi radian. If you have path difference of half lambda, means you have phase difference of pi radian. Okay kan, class? If you have a half wavelength path difference, then you have pi radian phase difference. Boleh kan, class? Okay, macam ini, class. Let us look at. What is mean? Okay, look at game. The very simple only. Path difference. Path difference means what? Difference in distance traveled by two light waves. Itulah maksud dia. Path difference means the difference in path. The difference in their path. Difference in the distance traveled. Difference in the distance traveled. So, for example, class, I give one very simple example. One very simple example. And then you can immediately see it. Okay, so let's say I have like this. Okay, so this is the first wave. Now the second wave. The second wave, let's say I put it here. Saya tarik ke sini. The second wave. See that? Okay. Be the second wave, I put it under color green. See? So the first wave and second wave. What are their path difference, class? What are the path difference? What the difference in the length? Maybe I should make it longer, this one. The second one, I should make it longer. Like that. Okay. What is the difference between the first wave and second wave? Which one travel longer distance? The first one or second one? Which one travel longer distance? Until, let's say, this point. This point. Yeah? Until this point. Which one travel longer distance? First wave or second wave? Which one travel further away? First wave or second wave, which one travel longer distance? Hey class, are you sleeping? Which wave travel longer distance?
First, sir.
Louder, I cannot hear your sound.
First.
First one, see? So the first one has a longer distance, isn't it? Good. So what's the path difference? What's the path difference? The difference in the path? 1 lambda lah, isn't it? The difference is 1 lambda difference. And what's the phase difference? What's the phase difference? 2 pi radian. Understand, class? Good. So now, let me okay. Good. Yeah, good. So now, let's change a bit. This time, let's change a bit. This time, make it here, class. Make it here. So let's change a bit. Oops, sorry. Okay, so I think like this. Okay, so what's the path difference now, class? Tell me, class, what's the path difference now? What is the path difference now? Which one? The number one is still travel longer distance, right? But how much longer? How much longer, class? Tell me.
Half lambda.
Louder, please. Louder. Delta L dia
Half
berapa?
lambda.
Ya? Yang lain tak bagi kerjasama kah? Yang lain tak sebut, langsung tak hiraukan pelajaran ini kah? Baik, saya tak payah ajar. Yang lain tak ada suara langsung. Berapa path difference dia, kelas?
Lambda over 2.
Lambda over 2, good. Ya, lambda over 2. Ya. So pi radian. Ya. So meter. So the phase difference ini path difference nya half lambda ini ataupun pi radian. Okay, are they coherent, class? Are they coherent? They are still coherent because they have the same wavelength. Kalau kita tengok dari sini pergi sini, dari sini pergi sini, it's still same wavelength. You see, kita tengok sajalah ya, tengok dari sini ke sini, dari sini pergi sini, they still have the same wavelength. So they are all coherent. They are all coherent. Why they are coherent? Because they have the same wavelength. Just that they got what? They both of them they got what we call it path or phase difference. Okay, class, I want to ask you one thing. When these two, let's say the first one, kita tengok first set. the first wave and second wave, when they arrive at, let's say this is the screen. Yeah, this is the screen. So what light do they see? When these two light, they interference with each other. Interference with each other. So what light do they see on the screen? Constructive interference or destructive interference? Bright fringe or dark fringe? Tell me, class. Kalau ini cahaya dengan cahaya pertama dan cahaya kedua ni tiba di screen, constructive interference or destructive?
Constructive.
Yeah, so they have constructive interference, isn't it, class? Constructive interference ataupun bright fringe. Susah betul, tahu tak? Tanya soalan tak jawab lagi, itu yang buat bikin meradang tu. Ya, nak tulis pun susah saya. So ini bright fringe. So they have a constructive interference. Okay. But if you have phase difference of only half lambda, so what happened, class? You see this one? Ini menjadi terbalik. Walaupun dua gelombang mula dengan ke atas, ini pun ke atas, tetapi kalau path difference dia lain, nampak tak? Ini path difference 1 lambda, ini path difference half lambda, tapi in the end apa terjadi, kelas? Ini pergi bawah, ini pergi atas. So apa terjadi di screen? Apa terjadi di screen, kelas?
Dark fringe.
Yeah, destructive interference. You get a dark fringe. See that, class? Get a dark fringe, class. So inilah pentingnya path difference. Inilah pentingnya path difference. It will make it you have constructive interference and destructive. You will produce bright fringe or produce dark fringe. Why? Okay, why is it like this? Because we have let's say a double slit. Yeah, double slit. So I just give a rough idea first. Yeah. So kalau di center cahaya same distance, dia punya distance sama. So they produce bright fringe lah. Tapi kalau when you going further away from here, see that? Kalau pergi ke sini. Ya. Kalau pergi ke sini, dia punya first wave dan second wave. First wave. So second wave itu first wave itu beginilah, tengok tak cahaya pergi sini. Ini screen lah, kelas, ini screen. Dan cahaya kedua tu pun pergi sana. So apa terjadi, kelas? Ada path difference, kelas. This path difference will cause either bright fringe or dark fringe, class. Sama ada kalau you punya path difference ialah dalam multiples of lambda, 1 lambda, maka dia akan produce bright fringe. Tapi kalau your path difference is half lambda, you produce dark fringe. So kalau dipergi ke satu tempat atas, let's say gelombang pertama itu shorter distance. It's a short distance. Kalau yang second wave, long distance. Long distance. So dia ada path difference dia, kelas. Ada path difference dia. So kalau path difference dia, sometimes it can have, kalau bright fringe in the multiples of lambda lah, 1 lambda, 2 lambda, 3 lambda akan produce bright fringe. Tapi kalau yang dark fringe yang ada half lambda tu, maybe is half lambda, or maybe is 1.5 lambda, or maybe is 2.5 lambda, dia akan produce dark fringe, class. This one I will cover tutorial lah. So I just want to give a big picture what you're going to learn, like this one. You see that? What you're going to learn in the future. Okay, so that's all for today, class. Do you get the big picture?
Yes, sir.
Ya?
Yes,
Boleh
sir.
faham kelas? This is
Boleh.
about interference lah. Okay. Thank you class.
Thank you,
Thank you,
sir.
sir.
Thank you,
Thank you,
sir.
sir.
Thank you,
Tengok
sir.
baru ada berapa pelajar.
Thank you, sir.
Ada
Thank
20
you,
orang
sir.
pelajar tak ada di sini. 23, 29. Okay.